In this lecture, we'll see multiple inheritance. It is not very commonly used as it can make the design quite complex and confusing. But it is good to have an idea about it as you might encounter it in some library or some other code. Till now, the inheritance that we have seen is single inheritance, which means that a class inherits from a single class. In multiple inheritance, a class can inherit from more than one base class. For example, this class X inherits from classes A, B, and C. All the data members and methods of all these three base classes will be available in this derived class X. This is the syntax of defining a new class that inherits from multiple classes. All the base classes are placed inside the parenthesis. So this statement creates a new class named X that inherits from classes A, B, and C. Here's an example of multiple inheritance. A teaching assistant is a student who teaches also. So this class teaching assistant inherits from both the classes student and teacher. Now let's go to idle and see some code. Here we have this class named teacher and this class named student, and this class teaching assistant is inheriting from both these classes. All these three classes have defined a method named greet. Then we have this instance of this class teaching assistant, and we are calling this method greet on it. Since this class has its own greet method, this greet method will be called. Let's run this. So the greet method of this class was called. Now suppose this class does not define this greet method. Now since greet is not present in this class, Python will look for it in the base classes. Now both the base classes have this method named greet. So which one will Python execute? Let's run and see. It ran this greet from the student class. It is because while searching the multiple base classes, the search is performed from left to right. Let's change this order and see. Now let's run this. So now this time the method from teacher class was executed because now this is on the left. All the base classes of a class can be seen using the dunder basis attribute. So let's see all the base classes for this class teaching assistant. We get this tuple with both the base classes, and the order of the base classes is the same as specified here. So this is multiple inheritance, but this is just one level deep. There can be multiple levels of inheritance. Let's see an example. This class is inheriting from these two base classes. Now these two classes could be derived from a common base class person. This is known as diamond inheritance. And we know that every class is derived from object. So this is the base class for person. So the whole structure can be quite complex, involving both multi-level and multiple inheritance. As the structure becomes complex, searching for attributes in base classes does not remain straightforward. So to resolve any sort of conflict while searching for attributes in base classes, Python uses a well-defined algorithm. The order in which Python searches for attributes in base classes is called method resolution order, or in short MRO. This MRO gives a linearized path for an inheritance structure. So Python computes an MRO for every class in the hierarchy, and the MRO is computed using the C3 linearization algorithm. This algorithm is quite complicated. You can check the documentation if you are interested in the details. But roughly it works in a depth first left to right manner. And it searches each class only once. For example, here the person class can be reached in two ways. But it will be looked up only once in MRO. We can see the MRO for any class using the dunder MRO attribute or the MRO method or using the help function. If we have an instance and want to see its MRO dynamically, we can use the dunder class attribute. Now let us go back to idle. Now we have made these classes teacher and student inherit from this person class. And all the classes have defined this method greet. Let us see the MRO for this class teaching assistant. This MRO is shown here at the top. So if we use any attribute on an instance of this class teaching assistant, first it will be searched in this class, then in student class, then teacher, then person, and then in this built-in class object. The search will stop as soon as the attribute is found. And if the attribute is not found in any of these classes, then an error will be raised. We can get the MRO in a tuple using the dunder MRO attribute on the class name. So here we got this MRO in a tuple. If we use the MRO method, we get this order in a list. So now we get a list. To find the MRO through an instance dynamically, we can use the dunder class attribute before the dunder MRO attribute. We have this instance X here. Let's use it. So again, we get the same MRO in a tuple. Now this method greet was executed on an instance of teaching assistant. And this class has its own greet defined. So this method was executed. Let's delete it from here. And let's run it. Now Python did not find greet in teaching assistant. So it searched for it in student, which is next in line in the MRO. So this method was executed. Let's delete it from here also. Next in MRO is this teacher class. So this method will be executed. Now let's delete this greet also. Now next in line in MRO is this class person. So this method will be executed. If we delete this greet from here also, let's see what happens. We get this error because next in line in MRO was object class and it does not have any greet method. So we got this error. So this is how Python looks for attributes in base classes. Although this order is called method resolution order, it holds true while searching for data attributes also.